Hello everyone, my name is Marian Alaoui. I'm technical artist for Epic Games, and today I'm very happy to present to you Electric Dreams from an idea to a demo. In this presentation, I would like to talk about how it started, the development of the features, and different tips that I could give you for this type of prototype or demo in that things. So the demo took about 3 months with about 20, 30 people, I would say. So of course, some people came in and for a few days to help on the VFX, for example, on the rendering, etc. So let's base on, let's say, about 30 people full-time during 3 months. So 3 months is not a lot, honestly. It was very short, especially that we had to create the entire demo, but also prototype different things, improve different features. So it was a good time, let's say. All right, so in every project or prototype, we generally start with an exploration phase. In our case, we wanted to explore the various updates from Nanite that was developing, for example, the mask material that was very important, or the world position offset working with Nanite. As you might know, most of the demo that we're using Nanite at Epic was mainly static, meaning that we were using mainly static geometry or moving geometry collections, mainly rocks, etc. So this time, we wanted to explore different options using these new features. And this is why Quixel started to develop last year, end of the year last year, this beautiful environment jungle. The goal at the beginning was definitely not to do a GDC demo. It was just to explore and test how this new feature worked. They know that mask material was something very great for the vegetation. We have a lot of vegetation in the Quixel assets, so they really wanted to start to develop something based on that. But, the more they were working on the jungle, the more we thought that something was missing. We wanted to have an extra things, that could empower, let's say, the beautiful environment of the jungle. So we tried at the beginning different things with characters, etc., but it was not giving us the good feeling about having something special for this first try. And we knew that this thing that was missing needed to be shiny. In fact, the entire demo was using rough materials for the vegetation, etc. So having an object that could be receiving more reflecting elements would be something that could be amazing in the environment. So the first thing, we can use the mannequin. The mannequin is a bit shiny, it has reflection, etc. But we knew that for just giving a try, we're going to have to add IK, we need to add many things, to have proper interaction with the ground. So we started to work with the animation team, but at the end we saw that it was a lot of work to just having some prototype. So instead, we were thinking that maybe we can use something else. We knew that we were working a lot with car companies before, so maybe it could be something that could be funny to try out. So let's give it a try. We took a car. At this moment, it was Rivian. We knew that because we were working with them for the HMI side, we had a car that was available for us to give it a try. This could be working, in off-road mode, so that would make sense to use it. So, all right, we're gonna try something. We first set the cameras, we set the physics, we set all that stuff, and as you can see, it's definitely not looking nice. It's way different than what we saw at the end, right? That's normal. It's just trying some things. So we try to see how the volume and how the size fits, in the camera and that kind of things. We wanted to try the different camera feelings about motion thickness and that kind of things. Of course, the physics of the car was very important to feel the weight of the car, but also the different controls that are gonna impact at the end the final car. So as you saw, it's just a prototype, but we had something. It was interesting. But now that we have the idea, we need to create this concept, meaning that we need to merge the two ideas together. In that case, that means that we need to try out different things. We need to improve what we had so far. So we took the time to explore the concept, meaning that we talked to Rivian about the idea, of course, because this needs to be approved by them. We cannot use any asset in the world without having any approval. So we talked to them, we discussed internally about how it could be done, who could work on this, and of course, what's the goal of this? Do we just want to still do just a try internally, or do we want at the end to reuse it for I don't know, learning purpose or that kind of things? So we took the time, and we wanted to just think about this to know what's next. So we took the beautiful environment that the Quixel did, and we put the car into it. That was pretty simple. But we try first also to improve a bit, the general looking to make sure that we weren't going to have like a mismatch between the two results. So the idea was to regroup, so all the ideas into this simple scene that Quixel was doing with that. And also, that was very good to understand what will be the future needs and the issue we might have. For example, this is an electric vehicle that we don't use to work. How the performance might go, because just having an environment is easy to steal pictures, but now maybe we want to have it running like at 30 FPS or 60 FPS. So we're going to have other issues to understand what could be the performance impact on this. And of course, in that case, we're going to have to list all the requirements of the features for the engineers or the artists at the end. But so this was working definitely, like we saw it was working in the environment of the jungle, but we had to try something different also to see like if the collision might work, how the feeling might be. So we did a try on like different test samples, such as like having just like the collisions and seeing how the impact of the performance could be. And this helped us to have like more flexibility, meaning that we could do this in different environments if we need to. All right, but now that the prototype is validated and everything seems to work, we are now ready to make the call about like what's next. Could we maybe do this for the GDC because it's January? Maybe this could definitely work for end of March. This is going to be 3 months of hard work, but if it's worth showing this, that could be really interesting in that case. So I think like the prototyping phase that we saw here was taking about like 20 days from nothing. So just from like, the basic environment to like the car having working with physics, having performance already starting to work, etc. And also having like an establishing list of what we want to have into this list. So we are like in mid-January, so 2.5 months left. So what's next in that case? We know that because this is going to be like a special demo, we want to put like a key on different elements. The 3 elements going to be, of course, creating something. It could be the demo, it could be features. We have to create, we have to innovate. Then we also want to improve what we already have to make sure that things going to be production ready in that case. And of course, this is something that we used to forget, but we have to test, we have to validate all the things. So on the creation side, of course, we're going to create a demo. So that's going to take some time, and that's going to take some resources. PCG was, of course, something that was coming on. We knew that PCG was could be like, ready for the GDC because they were working on it before, and we knew that it could be the good time to use it and to show it. Substrate, this one of the rendering features that was coming also along. We tried it before, but we never really show it in like a good demo. So this demo could be like a good validation for the use case of these new features. Chaosflesh, that was also something that was coming along. Same thing, we were like developing it, but no real project right now that was in the pipeline. So this could be like a good first time to show it publicly and also in a production phase. What did we improve? Of course, Lumen and Nanite was the main key, as we wanted to show something incredible, something very nice. Virtual shadow map was also something that we wanted to validate, as this gonna be like production ready. We want to make sure that we don't gonna hit any issues in that case. In the simulation side, the Niagara system for the water was extremely important because that was something new also, and we wanted to show it has a production-ready features. The Chaos vehicle was something that was, of course, the key features because we want to have a vehicle. So Chaos physics needs to work perfectly for our demo. And finally, DataSmith was important to validate and import all the assets in the demo. All right. So I would like to show you from here like all the different features that has been created and developed for this feature specifically, meaning that in general that in all demo that we have in Epic Games, we also try to use what we're gonna give you at the end, and we're gonna try to improve it. We're gonna make sure that this is gonna be production ready after that. So all the features that we have here are based on the 5.2. So of course, it moved a lot since then, but at this moment, things had to evolve specifically for this example. So rendering, as you might know, this is extremely important for us. We wanted to push this as far as we want, and as we can, mainly, because the time was short and we had to move forward with this. So lumen, nanite, substrate, and virtual shadow map was, of course, something extremely important for us. As this gonna be coming with jungle environment, we knew that lumen gonna create something unique, something special for the GI, and mainly with the scattering with the foliage. We never really did that before with this type of huge environment, and this was the first time that we wanted to do that for like a production-ready things. Another thing that was like causing us some issues, for example, was the screen space reflection, for example. In one of the images, you can see that the light of the back of the car was reflecting in one of the windows. That was not possible because in theory you have like occlusion. So in that case, that was one of the requirements to make sure that, hey, we need to have screen space working properly in order to have this ready for the 5.2. And of course, lumen had to work with substrate. I'm gonna cover it just after, but that was one of the main focuses, like making sure that substrate gonna cover all those things at the end. On the nanite side, so masked material was, of course, something new, and we had to validate that this might work before the release. So it was important for us to make sure that performance gonna work, and all the different issues that we could have need to work with this. So we need to track the performance and all that stuff. The wall position offset had to work because we're gonna have a lot of trees. So as you might know, we're gonna have winds, we're gonna have all those things, and having like a static environment cannot work. At the beginning, we didn't enable WPO because it was not optimized. It was not really working. But at the end, talking with the engineer developers, we had to find a way to improve these issues because we want the jungle to be alive. So that was very important. And finally, working with nanite, because we're gonna have a smooth car with nice curve, etc., we need to have high precision normal working properly, meaning that before that, we're gonna have like some broken edges in the reflection, and thanks to the fix they implemented into this in 5.2, we were able to have like this very nice looking curve on the reflection of the car. Finally, because everything that's gonna be working in nanite is gonna also impact virtual shadow map, meaning that we need to make sure and validate that virtual shadow map gonna be properly working with all those new features. And making sure that performance is going to work well. Finally, during the production, at the beginning, we were only using like the default material system. But at some point, because we implemented the car and we knew that substrate might be around the timeline, we really wanted to push the improvement and the stability of this feature. So we enable nanite and see like how things goes. If it breaks absolutely everything, or if it's working, we just need to do some small modification. And hopefully for us, we just had to do like minimum amount of work to have absolutely everything working properly. However, we spent most of the time, of course, on the car because we wanted to have the performance working with the vertical layers and all that stuff working properly. So during the development, we tested and we also improved how the UI was working, as that was something important because we knew that this is going to be ready in 5.2 as experimental features, but it still needs to be user-friendly. So we had to test it, we have to approve it. And finally, like stability improvement has been an amount of work that was important for the developers as they never tried in production. And of course, as you might know, during the production, everything might break because of like users doing A, and using B, etc., etc. So of course it break at some point. So we were here to support them and making sure that we had good repro and that kind of things to improve all the features of Substrate. All right, what's next? We have beautiful environment, but we're gonna have a car in here. So we need to also maybe improve the car. As this is gonna be an electric vehicles, we need to make sure that this is gonna be properly working. So in that case, it was crucial to make sure that the experience using the Chaos vehicle going to be as smooth as possible. So what was the list in that case? Of course, Chaos vehicle need to work properly with electric vehicles. Suspension was also something important as we want to have the feeling of the pressure of the heavy car on it. Chaosflesh was something that I was mentioning before that we wanted to implement in order to have like these extra things in the demo. And of course, all the interaction with the ground and wind environment was extremely important. So, talking about the Chaos vehicle, One of the first things is like, because this car could be like either like a road, like a normal road car, or it could be like an off-road system. We wanted to have and adjust the suspension based on the style we wanted to have. So as you can see here, we can like change the height of the suspension dynamically in order to make sure that we're gonna be able to provide the good physics for the final environment. Electric vehicle setup was something that was never really done before internally. So we wanted to make sure that this might work properly, having like a correct curve for the torque, because we don't gonna have like any shift or that kind of things. It needs to work, it needs to be as smooth as possible. So during the development of the electric engine system, we also took a lot to Rivian. So we give them some videos, and they were able to give us some feedbacks based on how it feels, how it looks, and that kind of thing. So it was very important for us to make sure that what we're gonna have here gonna be fitting the reality of the vehicle system. Finally, stability improvement always. As we are like pushing all the features to the limits, we need to make sure that this thing gonna be working properly at the end. So this was one of the very important things. Suspension. So we were talking about like the runtime suspension, but also when you're gonna move on rocks and that kind of things, we're gonna be able to see all the compression of the suspension happening. So everything in here was working with control rig, and because the Chaos vehicle was giving me like enough information, I was able to provide all the information to the control rig to apply the compression, to apply all the rotation and the momentum, etc., live without paying any performance. And because all of this feature might be expensive, I needed this to be working with Nanite in order to have it optimized. But how to do this? Because we know that the vehicle system is using skeletal mesh. But because all the pieces are static and we only have rotation, I was able to create like an empty skeleton without any meshes and just like reparent all the Nanite meshes onto the bones to apply then the good rotation, etc. So that was simple, but this could save us like tons of milliseconds at the end just by doing this. Finally, the Chaosflesh. So this is something that is like pretty new in our system, and because we wanted to have something special with Chaosflesh, we wanted to showcase it during the GDC demo. But we only have like vegetations and rocks and that kind of thing, so how we can apply like surface tension, for example, to trees, this is like, that doesn't make any sense. But hopefully we had the car, and a car, the only part that could be like compressed due to the weight is of course the tire. So we had to think about this. So the Chaosflesh really helped us because it generated all the data at runtime for the surface tension, meaning that it's also working with collision. So in that case, we're able to know like how to compress, how to manipulate the mesh based on the collision of the environment. Everything is nodal based, meaning that it's extremely user-friendly. You don't need to do any C++ code, etc. You have like an asset which that is working with nodes. You can specify like any tension information that will be working out of the box. This is working on a separate physics thread. So everything in here was generated on CPU, meaning that it might be expensive. This is generally like to pre-calculate things, but we wanted to use it at runtime. So because this thing was running on CPU, we had to make it optimized. So hopefully this is fully working on a separate physics thread, meaning that you can just like pay the cost of like 20 milliseconds in our cases, but because the entire system was like the GPU, etc., took also like 20 milliseconds, we were able to put the budget into it as a parallel task. All right, so now that we have like all the physics of the vehicle, now that we have a beautiful environment, we need now to have like this beautiful car, because the car we were using at the beginning was like about like 100 to 200,000 triangles. It's definitely not enough. We need to have something like high quality because we want to showcase Nanite. We want to showcase all the new updates. So we had to improve the visual fidelity of the car. In that case, we were using DataSmith to input the raw data coming from Rivian directly to import the car straight out of into the engine. So we're gonna cover in that case, I mean, what we cover in that case was DataSmith, that was very important, how to do some good tessellations, and of course the mesh preparation, that was extremely important, that I'm gonna cover just after that. So in the vehicle, with the inside and the outside, was about like 45 to 50 million triangles. So, and this is like just for the car, meaning that the entire environment was about like 1 billion triangles in general, or even more. This was like not making a huge difference because everything gonna be static mesh, so we can pay the cost in the night. So, because DataSmith was covering a lot of different extensions, we were able to import directly from Rivian their CAD data. That was very important. We choose and we tested internally again some different CAD solution in order to retessellate the system. Our internal system called CAD kernel was definitely helping us to have like fast import and that kind of things. However, we saw that sometimes it was creating like some issues, some infinite loop or VRAM issues, some RAM issues, sorry, that was taking about like 200 gigabytes of RAM. So trust me, like no one's do have this on the computer. Hopefully we do have some, but it was not normal. So we had to exchange, we have to talk with the DataSmith team to make sure that, hey, is there a way maybe this could fit in like a 10 or 20 gigabyte of RAM, not 200, that's not possible. So stability was definitely like something to improve in that case because we want this to be also recreated by other users. So we don't want to have like just us doing this example. So we want everyone to do this example. So we had to fix this issue. So yeah, so that was most of the issues we do had with DataSmith, but out of the box, it was definitely working fine. However, now that we have this beautiful mesh, we need it to look right. We need to look real. And that's where like all the preparation after the import had to start. The first thing is like we need UVs, but of course, as you might know, like unwrapping a 50 million triangle mesh is definitely not easy. Like no DCC can handle that. So we had to take the time, we had to do different solution in that case in order to prevent this issue. The time was our best case in that options. So we took the time to make sure that we're gonna generate the UVs for all the elements. Because we wanted to have like this nice little touch about like having the dirt on the car, and this needs to be hand drawn, and we cannot do any procedural things. So we needed to have the UV working. After that, we need the material ID also to be working because we want to have like the proper materials being applied on every element. And finally, in order to validate everything, we had to have reference images, meaning that all the work that we're doing needs to be based on reference to validate all the work, especially for Substrate that was in development. So we took a Rivian car and we take like pictures around it with like specific lighting, with specific condition, etc. And the goal at the end was to recreate this final environment that was outside into Unreal in order to match and validate absolutely all the data. All right, so we do have like all our bases, but now we want to go further away. We want to add like some extra things. And one of the things, as you might know, is Niagara. We wanted to give this final touch about like, hey, we are able to have this beautiful environment, but we want more interaction with Niagara system. So our first idea, and that was something we had in mind since a few times, was like, we want to add water in our demo. That could be really cool. That would be something new. And we want to validate that this water simulation system could work at runtime in that case. So the first thing in that case was the water. So the water solver was coming from a basic example, which was the 3D solver in the Niagara plugins. So you can enable it, you can play with it. So that's what we did. But at the end, we saw that we had an issue that it was not performing enough for us because we need to tweak some values, we need to tweak different things. So that was very important for us to make sure that the water gonna be working in that case. So we improved it, we talked to the developers, they were able to help us in that case, and we had the final result that was definitely working nicely. In that case, we knew that we wanted to have this water. So at the beginning of the demo, the Niagara team asked specifically to have 6 milliseconds for these specific features on the GPU. So that means that if we run at 60 FPS, 6 of the milliseconds, 60 FPS, so 16 milliseconds, 6 of the milliseconds gonna be just for the Niagara system, and that was tough. So we had to run, in that case, that demo at 30 FPS to make sure that we can run absolutely all the features at runtime in that case. Specifically that we want to run at a native 4K. So this was also like an exemption for this demo, but we wanted to run it like properly at 4K. So at the end, we choose to take the 30 FPS, meaning that 33 milliseconds, 6 milliseconds could be taken only for the Niagara system. So it is important in that demo to make sure that the VFX team gonna have the budget allowed since the beginning in order to add this feature into it. A new feature that was like extremely nice in 5.2 was also the mesh to UV. So meaning that now in Niagara, you were able to grab the static mesh and read all the UVs of this new mesh. Meaning that you can, so you take the UV, you can reuse it in a material as a render target, and based on that, you can do whatever you want. For example, in my case, in order to have this wet effect on the water, I was able to save in the render target the wall position of every pixel. And with this, I was able to then sample the water to then create a mask of water that could be added then on the car. So that was something extremely nice. This was running at runtime, and it was extremely performant. To give you some numbers, after the simulation was done, just by recreating like this new UV system, reading like the data, etc., it took me about like 0.05 milliseconds. So it was literally free. And thanks to this system, I was able to then reproject the water on the car. And finally, that was something that was working definitely nicely, was the decal mesh. So at the beginning, I started to like explore in order to see like how we can have this wet effect, behind the tires of the car. And so I was using like decals, I was using ribbons, but it was not working properly. And finally, a new solution came up that was very nice, was the decal mesh, that is like projecting a nice decal behind the car, has a trail effect. So that saved definitely my day. All right, the next topic, as you might all heard about, is the PCG, the Procedural Content Generation. So during the production of the demo, we knew that PCG might be something very interesting. It was already tested before internally, and we wanted to showcase this at GDC. But how to showcase that? We knew that we don't want to generate the entire level with PCG because that's going to be too expensive, and we might going to have at the end some issues if we don't take the time to spend into this. So instead, what we say was like, we're going to generate half of the environment with PCG, and the other half going to be handmade in order to validate and making sure that we don't going to have like surprise the day before we're going to showcase these kind of things. So PCG, it's like really easy to use as this is based on nodes, meaning that you can, any artist or technical artist or developers, etc., don't need to write any codes in order to generate a dynamic system. They can procedurally generate an entire environment without writing any codes or any blueprints. However, this allows you to create your own nodes if you need to. For example, you can create C++ node or blueprint node if you feel that something is missing into the graph. Everything is running at runtime or in editor, meaning that during the game, we were able to regenerate the environment directly live. Or in the editor, to make sure that we are happy with this one, we can generate in the editor and then save it as like the default level. Finally, it is important to know that all the features that we're implementing are performant. In our cases, it was important to make sure that this would run on multi-threaded system because this is going to be like something that could save you tons of time. It is also smart enough to know that if this is going to take more than a frame, so let's say if you're running at 30 FPS, if it knows that it's going to take more than 30 milliseconds to generate all the level, it's going to wait for the next frame in order to continue the work for you. Meta sound. As you might know, all demo need to work with proper sounds. And meta sound was one of the key features in our cases in order to make sure that everything might be working properly. In that case, we first need to know, like, we need to catch the environment. We need to understand how this could feel in this jungle. So they had, the audio team had to record most of the sounds in that case in order to make sure that we're gonna have like exactly what we need, what we feel in order to have this jungle alive. So most, in that case, of the sound was recorded for the demo. Finally, the sound that we are recording doesn't need to always work with like the engine reverb, meaning that sometimes it can apply some sound effect directly in your audio system in order to avoid having like some issues at the end in the demo. So it was important for us to not only rely on the engine reverb, as we want to have some type of control over it. In the game audio, of course, all the sounds that will be needed in the demo need to be unique, meaning that the compression of the suspension, for example, with the mechanical parts needs to be very important. The engine also needs to be something special. So we knew that all the sound that we're going to record for the car are going to be like unique. So we know that we're going to have to spend a lot of time in the audio in order to develop all the new features. So talking about the mechanical parts with the environment, for example, the suspension, when we're going to be in the water, we're going to have different impacts when we're going to be on the gravels or if we're going to be on rocks, etc. So the team, in order to catch this sound, took also a Rivian and bring them into like different environments. So they were able to test and record different sounds based on the height, for example, of the push of the suspension, how fast it could go, and what type of sound it could create at the end. The water was very important because we knew that when we're going to go inside the water, it needs to sound different. We need to feel that we are inside the water. So they had to do some R&D and some work with meta-sound in order to have like this nice feeling about like we are inside the water or outside the water. And finally, the engine. Because that's going to be the first time we're going to really like generate sound for an electric motors. How does it sound? How does it feel? So during the recording of the engine system, the audio team was able to have the core features of the sound, calling also the harmonics. So based on this, this is what you saw in the image. This is like literally the harmonics of the engine sound during a certain period. So based on this, they were able to regenerate the car engine directly in meta-sound using different noise, sound, and all that kind of things. So that was amazing. Definitely, like they did an amazing job on this. Finally, for the ambient sound, we were also using Soundscape in order to really like create this beautiful environment. And Soundscape helped the audio team to really have the feeling of this looping jungle system. Finally, there is also something that is extremely important for us, which is all the bugs and all the QAs. As you might know, during a production of a project, you're going to hit issues, you're going to hit bugs, you're going to need some help in order to validate all those things. And to me, it was extremely important to have some good communication with the team and having the proper tools in order to not falling into the loop of like, nothing is working, what do we do next? So regarding the bugs and the QAs, so one of the most important features was how to track the performance. As you know, all the features that we're going to create in Unreal Engine going to have to be working at 30 or 60 FPS or even more. So in our cases, we had to work a lot with the engineering team to make sure that all the performance going to be working. So we used, for example, in that case, Unreal Insight. That was extremely important for us to track any issues that we could have due to nanite, due to the number of triangles, due to lumen reflection and all those things. This, for example, helped us to understand like what option to choose. For example, between lumen reflection and using like hardware ray tracing or distance field. You might already have that options or this question before about like which one to use. And based on the performance you might gonna be able to put into the projects and the target or like platforms, this kind of tool was extremely important for us to understand which one to use. In our cases, for example, we didn't use hardware ray tracing because we didn't have the budget due to the size of the screen to allow the hardware ray tracing system. So we used distance fields. But then distance field is maybe not working as nice as we used to have before. So we need to then talk to the engineers. And that's where like the communication starts to kick in. So we had to create JIRAs. We had to Slack them. We had to create documents to explain all that stuff. And this really helped us and helped them to be efficient when we had any questions or issues in that case. On the communication side, as you might know, this was crucial. We all are working from home, so we we don't see each other, we cannot take a coffee and talk about the last issue we had. So it was important to make sure that we're going to be able to connect and chat with them at every moment if we had any issue. So that was one of the key features, like having peoples in the production team or in the QA team, etc., that are going to be always aware of what's going on. To give you some information about like how QAs worked in our side, for example, they were running every day some inside tracing in order to give us some information about how performance goes. This was extremely useful because anyone else at the company needs to sacrifice some of the time on the engineering team, for example, to just like trace it, because this could take like easily like 30 minutes because we need to build the project, we need to trace it, we need to analyze all those things. And thanks to the QA team, we were directly able to have like all the metrics in our hands and directly analyze all the informations. But then, as you might know, the final touch for us is extremely important because we want to make this demo unique. We want this demo to be very important for our users also because they're going to reuse at the end of the demo. They're going to reuse all the features. So we need to make these things special for the demo. For example, when we are going inside the car, we're going to have like this nice little introduction, this nice little animation with the light that's going to turn on, the light that's going to turn off, and all that stuff. This is going to make like this car alive, and this is going to feel that this is the right car that we're generating at the end. The dust and the dirt map was extremely important, but more than this, because we can just paint them, reusing the water system in order to change the wetness of the different maps was extremely important. So again, even if this is taking time, this is going to make, again, this demo very unique and very special in that case. The jungle environment, because this is going to be extremely important to make sure that everything feels right, it feels real. So the Quixel team spends all the time reworking on the jungle, reworking the path, reworking all the lighting at every moment in order to make sure that we're going to have the exact result we want to have. Not too shiny, not too bright, not too dark, etc. We spent a lot of time in the jungle to make sure that everything kind of looks right. The interior and the exterior sound, for example, this is something basic, but in the demo, we are able to go inside and outside of the car. And we want to have this sound being different when we are inside the car. We have like a little radio. We have like all the compression of the sound being outside being different than when you're outside. So this is all the small things that are going to make the demo very important. One of the things that I forget to mention also in the final touch is like making sure that all the product, all the features that we're going to develop, for example, with Lumen, are working. We had some issue, for example, that we saw that the contrast was wrong in the reflection of the car. So we started to chat with the developers. We started to see with the Lumen team to see like, where is it coming from? Is it coming from Substrate? Is it coming from Lumen side? Is it coming from any content? Is it coming from the lighting? Is it coming from the environment? In that case, you have like a lot of possibilities. And that's where you absolutely need to talk with everyone and making sure that you're going to track this issue at the end of the day. So what's the conclusion on this? We worked like hardly during 3 months on this beautiful project. We were super happy, etc. But we need to make sure that for the next demo we're gonna learn again from this, and we also want to give advice on what we learned at the end. What's the conclusion on this is like definitely the team efforts. Even if we're working all around the world in this demo, we knew that communication is going to be extremely important to make sure that all the issues are going to be tracked, because it is often happening that we are tracking some issues. Someone's going to say like, hey, I'm going to take it, but like no one's going to cover it at the end, and it's like forgotten somewhere. And the day before we're going to show it, we saw that the issue is still not resolved. So we have to create like important Jira. We need to wake up everyone in the US or in Japan or wherever at 4 a.m. to make sure that they're going to be able to fixing the issues. This happened, unfortunately. But that's something we knew that it needs to be improved and it needs to be working properly at the end in order to make sure that the communication is the key things to have something working properly, and also for the safety and the health of everyone. Thank you very much for your attention.